Okay, good morning, students. My name is Dr. B. Suresh Babu, working as a professor in Mechanical Engineering Department in MBR College of Engineering and Technology. As a part of online classes, today you are going to learn reciprocating balancing of masses. If you observe in the introduction of this fifth unit, it is divided into two parts. One is rotating balancing of masses. Second one is reciprocating balancing of masses. In the previous class, I have explained rotating of balancing of masses. We have solved 4 problems based upon the rotating masses. Still problems are there. We are going to discuss. Along with problems, another part is there, reciprocating balancing. Let us have a reciprocating balancing. The aim of the class is first why we need a balancing. Second one is what are the parameters that are going to present in reciprocating balancing, and what are the conditions that has to satisfy in reciprocating balancing. So these are the three basic aims we have to remember. For these three, I am going to explain by this today's slides. I repeat once again, the aim of the class is why we need balancing. Second, what are the parameters that are going to influence the reciprocating balancing. Third one is, what are the conditions that are needed for balancing of this reciprocating masses. For these three questions, you are going to get answers by listening this class. First, have this one. First question, why we need balancing? Often, an unbalance of forces is produced in rotating masses and reciprocating masses. Rotating masses and reciprocating masses due to the inertia forces associated with the moving masses. That means if the masses are going to move, then that are going to be the reason for unbalance of this machinery. Often unbalanced forces is produced in rotatory or reciprocating machinery due to the inertia forces associated with the moving masses. Balancing is what is meant by, so what first question, the unbalanced forces or unbalanced is due to the forces acting on the system. It may be rotary or reciprocating. Next, what happens in balancing? Balancing is the process of designing or modifying machinery so that the unbalance is reduced to an acceptable level and if possible is eliminated entirely. So balancing is the process of designing or modifying machinery so that the unbalance is reduced to an acceptable level and if possible is eliminated entirely. So what is an unbalanced forces and what are balanced forces? We can differentiate by using introduction of these reciprocating masses. So the balancing of reciprocating masses and introduction. If you observe various forces acting on the reciprocating parts of an engine. First, what is the reason? There are number of forces are there, that is number of various forces are there that are going to be act on the reciprocating parts of the engine. The resultant of all the forces acting on the body of the engine is due to inertia forces. Only is known as unbalanced force or shaking force. The resultant of all the forces acting on your body. If number of forces are acting on a body, due to that forces we are going to get one resultant. The resultant should be zero. If resultant is not zero, then it is going to be called as unbalanced force. That means whatever the forces that are going to act, one may be nullified with some other, but last if a resultant is there, that is a certain value is there, that value is going to be called as a unbalanced force or a shaking force. Thus the resultant of all the forces due to the inertia effects is zero, then there will be no unbalanced force. But even then an unbalanced couple or shaking couple will be present. Thus, if the resultant of all the forces due to inertia effects is zero, then there will be no unbalanced force. But even then an unbalanced couple or shaking couple will be present. So what this one? Thus if resultant of all the forces due to the inertia effects is zero, due to the inertia effect, resultant force is going to be zero, then there will be no unbalanced force. But even then an unbalanced couple or shaking couple will present. So if the second point, if you remember, although it may be resultant is zero, still a couple will be acting. That couple is going to be called as a shaking couple. So by this slide you have derived 3 points. First one is the forces acting on the engine. It may be a rotary engine or reciprocating engine. That forces are the reason for creating unbalanced state of a body. Second, if the resultant is zero, then also we are going to have a shaking couple or unbalanced couple. Next, when resultant is not zero on a system, then that leads to the shaking force or a unbalanced force. If you observe this slider crank mechanism, this is the slider is there, this is the crank wheel is there, and this is going to be called as a crank. Omega is equal to 2 pi n by 60. That is n is the rpm of this one. Omega is the angular velocity. X is the distance from the center to the center of this crank wheel. Then Fn is going to be perpendicular like this. This is parallel to this one, that is Fi. M is mass. Fr is going, that is a normal force, radial force. This is a tangential force. So when the crank is going to rotating like this at C, this sliding mass move like this. And then once again it is going to be coming to this far away point, means it will the far away from this one. And once again it is going to be rotating and coming to this point, means it will be moved towards the Fi direction. I think by this time L is the length here. This is the connecting rod is there. That is P to C distance is L. O to W is radius R, that is crank radius. Omega is the angular speed. Theta is the present angle between the radius and the axis of this crankshaft. X is the distance. So O is the point. BV, that is the forces acting in vertical direction. BH is forces acting in the horizontal direction. So FP is the force here. So vertical force, horizontal force at the crank position, normal force, radial force at the slider motion, and P is the point to be traced. C is the point to be traced on the crank wheel. So this is how we can explain the crank wheel. Remember, this figure is the key point. Whenever they ask any question, simply first you have to draw the question and explain the notations in this one. So whatever I told, the same thing is there. Balancing of reciprocating masses and introduction. Consider a horizontal reciprocating engine mechanism as shown in the figure. The same figure is there. Fr is the force required to accelerate the reciprocating parts. This is Fr, that radial it is going to act. Fi is the inertia forces due to the reciprocating parts. Fn is the forces on the sides of the cylinder walls or normal forcing acting on the crosshead guides. So Fr is the force required to accelerate the reciprocating parts. Fi is the inertia force due to reciprocating parts. Fn is the force on the sides of the cylinder walls or normal forces acting on the crosshead guides. Fb is the force acting on the crankshaft bearing or main bearing. Fb is the force acting on the crankshaft bearing or the main bearing. Since Fr and Fi are equal in magnitude but opposite in direction, therefore they balance each other. Since Fr and Fi are equal in magnitude but opposite in direction, therefore they balance each other. The horizontal component Fb, that is acting along the line of reciprocation, is also equal and opposite to Fi. The force Fbh is Fu is an unbalanced force or shaking force and required to be properly balanced. So if you observe, as per the previous slide, the notations are given clearly. I told normal force is there, inertia force is there, accelerating force is, that is Fr. Fb is the forces at the crank. Here vertical component is there, horizontal component is there over. The unbalanced force is Fu. So this has to be balanced and that is going to be called as a shaking force. So this is the notation which you have to remember first. So after drawing the diagram, you have to go for this one. Next, balancing of reciprocating masses and attraction. If you observe this one, the same notations are there. The forces on the sides of the cylinder walls Fn and the vertical component of Fb are equal and opposite and thus form a shaking couple of magnitude Fn into x or Fbv into x. So this is the x is the distance is there, Fbv into perpendicular distance is x, or if we take a horizontal one, that is Fbv into x. From above, we see that the effect of reciprocating parts is to produce a shaking force and a shaking couple. Since the shaking force and the shaking couple vary in magnitude and direction during the engine cycle, therefore they cause very objectionable variations. That means due to the shaking couple and shaking force, we are going to, that means it's going to produce very large noise, and at the same time due to the vibrations noise are going to be created, so which are very objectionable for a system to run in a very smooth manner. So this objection has to be avoided. How to avoid? By adding certain mass. By adding certain mass we can able to avoid that vibrations. If vibrations are avoided means ultimately we can able to get a smooth vibrations and noise also can be controlled. So that point, remember this one is we have to remove this objectionable vibrations that can possible by adding counterbalancing this forces acting on that one. That forces acting on that can be counterbalanced by adding the masses. Thus, the purpose of balancing the reciprocating masses is to eliminate the shaking force and a shaking couple. That's what I told. The purpose of balance is The reciprocating masses is to eliminate the shaking force and the shaking couple. In most of the mechanisms, we can reduce the shaking force and the shaking couple by adding appropriate balancing masses. But it is usually not practical to eliminate them completely. In other words, reciprocating masses are only partially balanced. I think you can already have explained this concept. Vibrations can be controlled by adding balancing of a mass. Still, in reciprocating, we cannot bring a system completely into balanced state. So what is meaning? By adding masses also, we are going to bring a system partially balanced only. So completely balancing is not possible as it is done in rotating masses. That's why reciprocating engines or reciprocating mechanisms are going to produce vibrations, because nullifying completely vibrations is not possible based upon this theory. That is the thing to be you can understand. So what is inferences from this slide? First slide is the forces are going to be opposite and equal. It may be horizontal direction or a vertical direction. It can be represented by Fn into x or Fbv into x. Vertical component or normal component, here two are there. Here it is Fn they have written. If you here means Fbv into x direction. The reciprocating parts are going to produce shaking couple and shaking force. This has to be balanced. This can be done by adding a balancing mass, but still it cannot be nullified to zero, because in reciprocating masses total nullification is not possible. So let us have a one method to find the velocity and acceleration for this slider crank mechanism. If we observe from P, consider the motion of a crank connecting rod of reciprocating steam engine as shown in figure. Let OC be the crank. OC be the crank and PC, already I told PC is the connecting rod. Let the crank rotates with angular velocity of W radians per second and the crank turns through an angle theta from the inner dead center, briefly written as IDC. Let x be the displacement of the reciprocating body P. P is the reciprocating body P. The displacement is going to be x be the displacement, that is it has changed from P to P dash. If it is originally P dash means change it to P. Reciprocating body P from IDC after t seconds, during which the crank has turned to an angle of theta degrees. Due to displacement in P, the change in the crank angle is going to be theta. So let here. So motion of a crank and connecting rod of a reciprocating steam engine. L is the length of the connecting rod between the centers. R is radius of crank or crank pin circle. Pi is the inclination of connecting rod to the line of stroke PO. Pi is the inclination of connecting rod to the line of stroke PO. N is the ratio of length of connecting rod to the radius of the crank. So N is the ratio of length of connecting rod to the radius of the crank, that is equal to L by R. N is the ratio of the connecting rod to the radius of the crank, that is L by R. Since acceleration is rate of change of velocity, therefore acceleration of the piston P is equal to velocity derivating the velocity, that is dvp by dt, that is dvp by d theta is equal to d theta by dt, that is dvp by dt into omega. Omega is 2 pi n by 60. N is the rpm. The theta is going to be the rpm, means we can write like this. Next, differentiating the equation 4 with respect to theta, that is dpp by d theta is equal to omega r into cos theta into 2 cos theta into 2 by 2n, that is omega r is equal to cos theta plus cos 2 theta by n. Substituting the values of dVp by d theta in the above equation, we have AP is equal to omega into r cos theta plus cos theta by n into omega, that is equal to omega square r into cos theta plus cos 2 theta by n. So substituting the value of dVp by d theta in the above equation, we have AP is equal to omega into r, that is cos theta plus cos 2 theta by n into omega, that is omega square r into cos theta plus cos theta by n. So these are the conditions if I mention. So already I told the aim is what are the parts that are going to cause unbalancing. The parameters. The parameters are, one is acceleration, second one is velocity, crank radius, and the angle making with the crank radius, and P, that is displacement. So these are the parameters that are reasonable, that are not reasonable, that are reason for creating the vibrations. So if you observe based upon this equation, when crank is at the inner dead center IDC, then theta is equal to 0. Then the condition is equal to omega square r into 1 plus 1 by n. Second, if the crank is at outer dead center, that is ODC, then theta is 180 degrees, that is equal to omega square r into minus 1 plus 1 by n. As the direction of motion is reversed and the outer dead center therefore changing the sign of the above expression. For example, if you observe the figure, if you observe, if this is inner dead center, this is outer dead center. For inner dead center, the theta is going to be 0. Then we are going to get omega square r into 1 plus 1 by n. If it is reversed, if it is at ODC, then that is automatically minus 1 plus 1 by n. It may be reverse, means the same thing happens. So what is the condition means? First one, theta may be 0 or theta may be 180 at this theta value. Based upon that one, we are going to get this omega square r into minus 1 plus 1 by n. So this is important thing we have to remember. Then the factors going to be affect are angular speed, radius of the crank, n is the slider to crank ratio, L is equal to uh, n is equal to L by R. We can observe means, if you observe this, n is equal to L by length of the connecting rod to the radius of the crank. That is L is equal to L by R. Next, we have already discussed that acceleration of the reciprocating parts approximately is given by the expression that we have derived. AR is equal to omega square into R is equal to cos theta plus cos 2 theta by n. Therefore, inertia forces due to the reciprocating parts. So F1 is equal to Fr, that is equal to mass into acceleration, m into omega square into r, cos theta plus cos 2 theta by n. We have discussed in the previous article that horizontal component of the force exerted on the crankshaft bearing, that is FBH, is equal and opposite to inertia force Fi. This force is an unbalanced one and it is to be denoted by Fu. I repeat, already Fu is called unbalanced force. It is due to the shaft bearing FBH is equal and opposite to inertia force, that is Fi. This force is an unbalanced force and is denoted by Fu. So unbalanced force Fu is equal to m into omega square r into cos theta plus cos 2 theta by n. So m omega square r cos theta plus m omega square r cos 2 theta by n, that is Fp plus Fs. That means one is called as a primary unbalanced force and Fs is going to be called a secondary unbalanced force. So primary balanced force is represented by m omega square r cos theta and secondary unbalanced force represented by m omega square r cos 2 theta by n, where n is equal to L by R. L is the connecting rod, R is radius of the crank. M is the mass, R is the correct, omega is angular velocity. So primary unbalanced force is equal to Fp is equal to m omega square r cos theta, and second unbalanced force Fs is equal to m omega square r into cos theta by n. So from this slide, we have found 2 points. First one is what is the primary unbalanced force and what are its secondary unbalanced forces. So primary unbalanced force is there, second unbalanced force is there. In the previous slide, we have found out the angles. Angle is going to be theta, that is at one point, that is IDC. Theta is at 180 means that is another point. So based upon this one, primary unbalanced force is Fp is equal to m omega square r cos theta. Second unbalanced force is equal to m omega square r into cos theta by n. Next. Next conditions. If you observe these conditions, if you come to this one, let us have this. The primary unbalanced force is maximum when theta is equal to 0 or 180 degrees. Thus, primary force is maximum twice in one revolution of the crank. Thus, primary unbalanced force is given by m omega square into r. So, what are the conditions? When theta is equal to 0 or 180 degrees, we have a maximum unbalanced force to be remembered. Next, the secondary unbalanced force is maximum when theta is equal to 0 degrees, 90 degrees, 180 degrees and 360 degrees. Thus, the secondary force is maximum 4 times in one revolution of the crank. The maximum secondary unbalanced force is given by Fs is equal to m omega square into r by n. So first condition is primary balance force is twice in one revolution. Secondary balance force is 4 times in one revolution. From above we see that secondary unbalanced force is 1 by n times the maximum primary unbalanced force. If you brought the relation between primary and secondary forces, it is 1 by n times the primary unbalanced force. In case of moderate speeds, the secondary unbalanced force is so small that it may be neglected as compared to primary unbalanced force. If the vehicle is rotating at a slow speed, we can able to neglect that one. That is a second unbalanced force is neglected. The unbalanced force due to reciprocating masses varies in magnitude but constant in direction, while due to the revolving masses, the unbalanced force is constant in magnitude but varies in direction. If you observe, the unbalanced force due to reciprocating masses varies in magnitude but constant in direction, while in revolving masses, the unbalanced force is constant in magnitude but varies in direction. So for reciprocating mass, it is going to be constant in direction but varies in magnitude. But in revolving masses, varies in direction but constant in magnitude. So we have a 5 basic conditions that we have remembered. I repeat once again. First condition is and primary forces are maximum at 0 and 180 and will come 2 times in one revolution. Secondary balance forces are comes 4 times 0, 90, 180 and 360. It comes 4 times. Next, when compared to secondary unbalanced force, it is 1 by times the maximum primary unbalanced force. In case of moderate speed, secondary balance force can be neglected. The unbalanced force at reciprocating masses varies in magnitude but constant in direction, while due to the revolving masses, the unbalanced force is constant in magnitude but varies in direction. That means for reciprocating mass, magnitude is going to be vary, direction is constant. In revolving, this is reverse. So this is how I have framed the slides for this class. Already complete notes is available in a department link as well as the Google Classroom code students. So before closing this one, let me summarize the concept. First, I have defined revolving and reciprocating masses are have unbalanced forces. These unbalanced forces can be balanced by adding a mass. The mass by adding in reciprocating parts also we cannot able to bring into a complete balanced stage. That's why we are going to be call it as a partial balancing. In partial balancing, we have two types. One is primary balancing is there, secondary balancing is there. So we have derived the two formulas. Very important point. For explaining this concept, we have taken the slider crank mechanism. Whenever the question asks, you simply draw slider crank mechanism, explain the notations, and go for primary balanced force and secondary balanced force. In all this one, important point is when resultant is not zero, then that is going to be called the shaking couple. No, sir, shaking force or unbalancing force. If resultant force is zero also, we are going to get a unbalanced couple. So by this, I'm going to conclude the class students. If you have any doubt, mail to me. The mail address is cheer5 of rediffmail.com. Okay, see you students. By this, today's presentation is over. Have a good day. Bye. See you all.